Okay, now we'll do another reaction, and this reaction is used for distinguishing purpose for different aldehydes and ketones. The reaction is called iodoform reaction. Already you have got this reaction. Alcohol also can show iodoform reaction, but as you have got iodoform reaction shown by some particular alcohol, not by all alcohol. Similarly, some particular aldehyde ketone can show the iodoform reaction. What was iodoform? Iodoform means this compound is called iodoform, CHI3. Actually, in this reaction, this compound will form, and that is why the reaction is called iodoform reaction. You know chloroform. Chloroform is CHCl3. Similarly, here iodine present, that's why it is called iodoform. CHBr3, this is called bromoform. So like this, chloroform, bromoform, iodoform. In this reaction, iodoform is produced as the product, and it gives the yellow color precipitate, and that's why the reaction is named as iodoform reaction. Now, although aldehyde and ketones can show this iodoform reaction, but some particular aldehyde ketone can show this reaction. Those aldehydes or ketones which contain this group CH3C double bond O, this group must be present. Then the aldehyde or ketone can show this iodoform reaction. I mean, this group must be present in your aldehyde or ketone. For example, I'll give one example. HCHO, this is the methanol one, and this is your CH3CHO. This is called methanol, this is called ethanol. To show the iodoform reaction, what group should be present? CH3C double bond O. So here CH3C double bond O is present, and that is why ethanol can show iodoform reaction, but methanol cannot show the iodoform reaction, because in methanol you don't have CH3C double bond O group. So that is why all aldehyde cannot show your iodoform reaction. Similarly, if I consider this one, CH3C double bond O, CH2, CH2, CH3, and this is another ketone. If I write like this, CH2, CH3, this is called pentane 2-on, and this is called pentane 3-on. Both are similar compounds, same formula, and only the position of functional group are different. That's why these two are called position isomer. So pentane 2-on and pentane 3-on, which one can show iodoform reaction? Since to show iodoform reaction, this group should be present. So in pentane 2-on you will get this group, but in pentane 3-on, here ethyl group is present. After ethyl, the C double bond is present. That's why it cannot show the iodoform reaction. One methyl group, then the C double bond should be present. But here ethyl is present. That's why pentane 3-on cannot show the reaction, but pentane 2-on can show this reaction. And that is why in exam, if the question asks how to distinguish pentane 2-on and pentane 3-on, then you have to write pentane 2-on can show the iodoform reaction, but pentane 3-on cannot show iodoform reaction. After that, you have to write the reaction. So that is called the distinguishing method. Give a chemical test to distinguish the following pairs of compounds. That type of question will ask, and you have to write the reaction. So now I will show you about the reaction. This is one of the aldehyde, CH3CHO. When it reacts with, in iodoform reaction, always iodine and sodium hydroxide is used as reagent. In alcohol also you have got iodine and sodium hydroxide you have to use as reagent for iodoform reaction. Then this alpha carbon, this carbon will produce the iodoform CHI3, and it gives yellow precipitate. And since one carbon is involved in your iodoform, here two carbon present, another carbon will form a carboxylic acid, salt of carboxylic acid like this. One carbon involved in iodoform, another carbon will form a salt of carboxylic acid, and the side product sodium iodide water you will get as the side product. So ethanol, when reacts with iodine and sodium hydroxide, it produces the yellow precipitate of iodoform, and this reaction is called the iodoform reaction. So when you write the iodoform reaction, always use iodine and sodium hydroxide as reagent. Similarly, if you want to take another example, this is propanone, CH3C double bond O CH3. So here it contains this group, that means it can show iodoform. when it reacts with iodine and sodium hydroxide, then you will get the iodoform CHI3. So one carbon produce the iodoform, another 2 carbon left. So this another 2 carbon will form the salt CH3COO Na, I mean sodium salt of acetic acid, and the side product will be sodium iodide and water. And this compound gives the yellow precipitate. So in exam, if the question asks how to distinguish methanol and ethanol, then you have to write ethanol can show iodoform test, but methanol cannot. After that, you have to write the ethanol reaction. So this is the process to distinguishing them. If you consider this one, acetophenone and benzophenone. I have given both the compound when we have done the naming nomenclature of your ketone. Then I have given these two compound. Acetophenone means benzene contain COCH3. Then this compound is called acetophenone. And benzophenone means there are two benzene ring like this, and in between them you will get the C double bond O group, carbonyl group. So this is acetophenone, this is benzophenone. Now here you have seen, if you want to distinguish between acetophenone and benzophenone, then you can use the iodoform reaction, because acetophenone contains CH3C double bond O group, but benzophenone do not have CH3C double bond O group. So that is why you have to write the answer as acetophenone can show iodoform test, but benzophenone cannot show iodoform test. After that, if you want to write the reaction with acetophenone, then it gives the, since it is alpha carbon, so it will produce the iodoform CHI3, yellow precipitate it will give. Now benzene and one carbon is left, that's why the carboxylic acid will be like this. This is your benzene, and it will become COO. Like this, you will get a sodium salt of benzoic acid. Side product will be sodium iodide and water. But here in benzophenone, since the CH3 group is absent, so when it reacts with iodine and sodium hydroxide, it cannot show iodoform. That's why you can write no yellow PPT. I mean no reaction. But here you will get yellow PPT. So like this way, you can distinguish acetophenone and benzophenone. So those aldehydes and ketones which contain CH3C double bond O group, that type of aldehyde ketone can show the iodoform reaction. So that is why in road mapping question, an organic compound A can show DNP test. Can show DNP test means it may be aldehyde, it may be ketone. After writing that, you will get the idea your compound may be aldehyde or it may be ketone. After that, the question given, the compound can reduce Tollens reagent. When it is given like that, Tollens reagent can reduce by aldehyde. That means you can sort out the compound. First time you have got the idea your compound may be aldehyde or ketone. When it can reduce Tollens reagent, that means your compound is aldehyde, not ketone. After that, if it is given, it can show iodoform test. I mean your compound is aldehyde, but your aldehyde should be like this, which contain this group. So like this way, you will get the idea about the compound, which compound is given in your question. In road mapping question specially, you will get the idea about the compound. If the compound show iodoform test, then your compound must contain this group, whether it is aldehyde or ketone, this group must be present, otherwise it cannot show iodoform reaction. And if the question is given the compound cannot show iodoform reaction, that means this group should be absent. I mean CH3C double bond O group should be absent. So like this way you will get the idea in your question answering. Thank you.